So next we'll discuss the major minerals, beginning with an overview. Essential inorganic elements that are needed in small amounts for function, growth, and maintenance of tissues. Major minerals, you need about 100 milligrams of or more per day, and they are stored in larger quantities in the body. In the next chapter, we'll talk about trace minerals. Before I go on, I should just remind everyone that when we talk about inorganic in this context, we mean it is not carbon containing. Here is a summary that shows both the major and trace minerals and how much we have in the human body. And you can see just how much more we need of the major minerals than the trace minerals. So just for context. Minerals, they come from a lot of different food sources, and we're going to go through those in more detail with each. But the bioavailability of the minerals can really vary based on the source. A lot of foods are being fortified. For instance, iron is being added to milled grains. Table salt is fortified with iodine. Orange juice is enriched with calcium. And these are efforts to ensure that people are getting enough of the minerals in a bioavailable form. A lot of factors will influence to what extent that mineral is going to be absorbed, and part of that is a physiological need. Typically, as the need for that mineral increases, so does the body's ability to absorb it. And again, certain ones are just more bioavailable than others. Some factors that increase that bioavailability include normal gastric acidity, so you want that acid environment in the stomach. Vitamin C intake, that is particularly important in terms of enhancing the bioavailability of iron in particular. Good vitamin D status, and that in particular helps the body to absorb calcium. Some factors that can decrease bioavailability include a lower level of acid in the stomach, phytic acid in whole grains and legumes, oxalic acid in leafy vegetables. That one is especially important because it interferes with calcium absorption. Polyphenols, which are in tea, coffee, and red wine, and then high-dose supplements of single minerals. This is one of those reasons that unless a deficiency has been identified and a doctor has recommended a supplement, typically you're better off sticking with a multivitamin than consuming a high dose of just one, because it can block absorption and bioavailability of others. So I kind of talked about some of these from that previous table, but again, in particular, you definitely want to remember that vitamin C will improve iron absorption, and vitamin D improves 3 different minerals, all of which impact bone health, but in particular, remember that in terms of absorbing calcium. And then again, that hydrochloric acid in the stomach will convert some minerals to more bioavailable forms. We'll talk briefly just about how minerals are transported and stored. So they can travel freely in the blood, or they can be bound to proteins. Trace minerals tend to be found when they are found in the free form, tend to be highly reactive. Now, the storage will vary. For instance, calcium and phosphorus are stored in bones and teeth. Iron is stored in small amounts in the liver and in the bone marrow. And trace mineral storage, we saw that bar graph earlier, that's very small. Just a broad overview of functions of minerals. Water balance requires sodium, potassium, calcium, and phosphorus. Nerve impulses rely on sodium, potassium, and calcium. Coenzymes include magnesium, copper, and selenium. And components of body compounds include iron and hemoglobin. Then growth and development of the body and brain require calcium and phosphorus. Broadly, I'm talking about mineral deficiencies. Calcium, potassium, magnesium, and iron are the major minerals likely to fall short of DRI recommendations. So those are the ones that we worry about the most. When it comes to trace mineral deficiencies, zinc and iodine are both of concern. Now, excess mineral intake can, in some cases, be toxic. iron and zinc are particularly of concern, and we'll talk more about that when we get to each of those minerals. But this is why, again, you want to carefully consider supplementation. I already mentioned higher intakes of one can hinder the absorption of others, and sometimes supplements can be contaminated, as with lead, and that can also be toxic. But now let's get into talking about some specific nutrients, start at the major minerals at this point, and we're going to start by talking about sodium. 1 teaspoon of salt contains about 2,300 milligrams of sodium. Where does most of the salt in our diets come from? A lot of people think of the salt shaker, but actually processed foods and foods that we eat in restaurants are the major source of sodium in our diets. Only about 10% of sodium in the typical American diet comes from sodium that is found naturally in foods, and about 10 to 15% of sodium in the typical American's diet comes from cooking or adding salt at the table. So you can see that by a wide margin, processed foods and restaurant foods, which make up most of the rest of the sodium in our diet, they really are the larger concern when it comes to getting excess amounts of sodium in the diet. And this is because the more that a food is processed, the more sodium it contains. So you can see a lot of great examples here. Just to point out a couple. So just a cup of uncooked rice has no sodium in it. But if you have a cup of rice-a-roni, that goes up to 580 milligrams. So a packaged rice-like product, rice-based product, maybe is fairer to say. Then 1 cup of fried rice has 705 milligrams of sodium. You can see some examples here of potatoes, apple, a medium apple, 0 milligrams of sodium, but then an apple muffin, you jump up to 165, a slice of apple pie, 400 milligrams. And again, all these examples are, I think, very eye-opening if it's not something that you have thought about before. When it comes to our needs, you can see that for most people, the tolerable upper intake level, or the maximum that we should be consuming, is about 2,300 milligrams. Now remember from a couple slides ago, that's 1 teaspoon of salt. So 1 teaspoon of salt all day long is the most that we should be consuming in a day. And for a lot of people, the recommendation is to consume less than that. So you can see for people who are 51 years or older, the recommendation is to stick to 1,500 milligrams of sodium per day or less, as well as high-risk populations, which include all African Americans of any age, individuals with hypertension, diabetes, or chronic kidney disease. And the American Heart Association recommends that Americans consume 1,500 milligrams or less. Now, I will tell you that there is research out there that tells us that some people are more salt sensitive than others. And therefore, for some people, cutting down on sodium won't necessarily lower the blood pressure by too much. And this is why these recommendations are for so many people to have a lower intake of sodium. And that's because they're at higher risk for hypertension or high blood pressure. But most nutrition experts suggest that it is still good practice to watch sodium intake, just to be cautious about it. And we'll talk a little bit more about other recommendations as we discuss hypertension in more detail in just a bit. Now, sodium does serve several important functions in our bodies. It is involved with glucose and amino acid absorption. It's required for normal nerve and muscle function. Again, that sodium-potassium pump, which we looked at briefly in the first lecture for this chapter. And it aids in water balance as well. Is it possible to get a deficiency? Well, 90% of American adults consume more than the adequate intake, which is 1,500 milligrams per day. And fewer than a third consume less than the daily value of 2,400. So for most Americans, this really is not a concern. Excess sodium, though, again, it increases the risk of hypertension. Remember, that's high blood pressure, as well as the risk of heart disease and stroke. Greater than 2 grams a day leads to more calcium being excreted in the urine. So that can definitely be very dangerous as well. And this is a link if you're interested in reading it. You can click on it in the slides posted on the course page about New York City, which launched a rule that restaurants need to post warnings for high sodium items, which again, remember, foods eaten in restaurants or fast foods tend to be especially high in sodium. Just to make sure you are aware of what we're talking about with hypertension, we're looking at blood pressure, which at a normal level, the recommendation is that it be below 120/80. So when it hits 140 or higher, over 90 or higher, then the individual is in hypertension. And so again, this is where we see these recommendations for people who are at risk for high blood pressure to decrease their sodium intake. Let's talk a little bit more about nutrition recommendations involving hypertension. Healthy lifestyles can help prevent hypertension. So for people who are at a higher weight beyond what's recommended for their height, weight loss is recommended. It's also recommended that people limit sweets, sugary drinks, and red meat, eat a diet high in fruits, vegetables, and whole grains, engage in regular physical activity. Again, we see this limiting the sodium intake, keep their alcohol intake under control, increase potassium. This is a major recommendation, and a lot of Americans aren't getting enough, as well as increasing calcium, magnesium, and fiber intake. And finally, what I at least think is kind of a fun recommendation is to consume foods that contain flavonols, including dark chocolate and cocoa. Another major recommendation for managing or preventing hypertension is for people to follow the DASH diet, and that stands for Dietary Approaches to Stop Hypertension. This diet is low in saturated and total fat, as well as cholesterol, and it's high in fruits, vegetables, and low-fat dairy. So it's rich in magnesium, potassium, which I mentioned is really important, as well as calcium and fiber, but without the use of supplements. Something I'll add, if you're interested in learning more about the DASH diet, is that it is also not as low in sodium as the recommendations we discussed earlier that are espoused by the American Heart Association. So some of the science behind this diet indicates that if the diet is rich in magnesium, potassium, calcium, and fiber, and lower in saturated and total fat and cholesterol, that the need to restrict sodium by so much is actually negated. So something to think about, that if the overall diet is balanced and healthy, then salt restriction may not be so important. And just as an aside, drug therapy is certainly often used as well to manage hypertension. Next, we'll talk a bit about potassium. Now, this is found in many foods that are unprocessed. Fresh fruits and veggies, meats, dairy, grains, coffee, and tea all provide potassium. So do certain salt substitutes because they contain potassium chloride. Our needs for potassium are about 4,700 milligrams per day. You don't need to remember that number. Most adults do need to increase their potassium intakes. Most Americans do not consume the recommended amounts of potassium. You can see here examples of a lot of different types of foods, especially a lot of fruits, vegetables, and dairy foods, as well as plant-based proteins that are relatively high in potassium, so adequate sources of this nutrient. Potassium is the major cation in the cell. It has a lot of the same functions as sodium. Remember, again, the sodium-potassium pump. And it can help normalize high blood pressure as well as reduce effects of high sodium intake. So this is one of the reasons that a diet high in potassium can help sort of balance out a diet that tends to be a little bit higher in salt or sodium. Deficiencies can occur if over a long-term period someone's not getting enough potassium, or if they are losing excessive amounts through urine or feces. They can also get too much, and that can be life-threatening. Typically, that's going to occur when kidney function is poor, and the body isn't able to balance and excrete potassium levels. This can lead to an irregular heartbeat or even cardiac arrest. In more mild cases, just intestinal upset. But again, it's mostly only a concern for people who have impaired kidney function. There's no upper level set for potassium, so for most healthy individuals where there's no kidney function impairment, you can consume potassium in large quantities without any concern.